All right, we're about to get a new definition called conditioning, conditional probability. And this describes a situation where you learn something about what happened. So for example, let's say that I toss a coin 3 times. Let's see how hard we get this example to be. All right, and we're going to assume that everything is nice and clean and fair, and so we have a uniform probability distribution on what? What are our outcomes that we have a uniform probability distribution on? What are the outcomes? Each toss can give me a head or a tail. 3 tosses gives me a sequence of length 3, comprised of heads and or tails, right? So it's uniform distribution on this set of things that look like this: heads, 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 tails, heads, tails, heads, tails, heads, heads. How many are there in all? Should we write them all down? No? Okay, there's 8 in all, right? Because I have 2 choices. There's 2 possibilities for what the first toss gives me, 2 possibilities for what the second toss gives me, no matter what the first toss gave me, and 2 possibilities for what the third toss gave me, no matter what the first and second did. So 2 times 2 times 2 is 8. So far, so good? Okay. So what is the probability that I get 3 heads? What is the subset of outcome space that corresponds to getting 3 heads? There's just one element there, right? I have to get heads on all 3 tosses. So that's heads, 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 which is 1 over 8. There's only one elementary outcome there. There's only one element in that subset. Okay, there's 8 elements in all. They're equally likely. We're using the uniform distribution. That's kind of what we mean by a fair coin. Okay, so now suppose that somebody tells me that the first toss gave me a head. What's the probability that I get 3 heads in the 3 tosses in all? All right, so I've learned something new. It's learning in this sense of the way you sort of update a probability to account for new information is called conditioning. So what we want to find is what's the conditional probability of getting 3 heads given that the first toss gives you a head? Okay, so 1/4 is what people are saying, and I agree. And now we just want to make it formal. Okay, so probability of 3 heads given, so use a vertical bar to denote given. First toss gives a head is equal to 1/4. What are we doing? We're basically saying, well, I know that the outcome is one of the outcomes that has heads as the result of the first toss. Yes? So how many of those are there in all? 4. Yes? let's write down what those are. Heads, heads, heads. That's the one I care about. Heads, tails, heads. Heads, heads, tails. Heads, tails, tails. Right? Okay. I know that this happened. The outcomes in here are still equally likely. In one of these four, I got all three tosses were heads. And so the conditional probability of 3 heads, given that the first toss gave me a head, is 1/4 instead of 1/8. All right. This is kind of heuristic. There's actually a definition going on here. Right? We've kind of got an intuitive feel for what's happening, but there's really a definition, and the definition is this, that the conditional probability of an event A given B is equal to the probability of the intersection divided by the probability of B if the probability of B is positive. Right? We don't divide by 0. All right. That's what we just did. The probability of 3 heads given head on the first toss is the probability of 3 heads and heads on the first toss. That's 1/8, right? To get 3 heads, we had to have a head on the first toss. So in this case, this is 1/8 divided by, what was the probability of a head on the first toss? It's those 4 outcomes out of the 8 possible outcomes. So it's 1/8 divided by 1/2, which is 1/4. So that's what we just calculated. But we were kind of, intuiting our way through it rather than doing something rigorous. In fact, this is the definition. So I use 3 bars indicating that this is a definition. In this particular case, it reduces to this. Okay? So that's conditional probability of A given B. And it's used to describe learning something. Yes?
What's the line mean?
Given. No, it's not. So if these were logical propositions, then this would be or. But this is conditional probability. So we're going to have different context. The vertical bar here is pronounced given. And it's defined exactly this way. What's the chance of A given that B occurred?